Welcome everyone to Seatrade Cruise Talks. I'm John Sifling, Seatrade Cruise Ambassador for Safety and Sustainability, and with me today is Maikel Arts, Head of Cruise at Wärtsilä. Good to see you again, Maikel.
Thank you, John.
Maikel, today we're here to talk about the cruise industry's journey to net zero carbon emission. But before we do, maybe you could tell us a little bit about yourself. I mean, you and I are familiar because you've spoken many times at the Safety and Sustainability Theater at Seatrade, but I think some folks listening today may not know so much about what you do, your bio, and what you do at Wärtsilä. So can you just give us a little overview?
I work at Wärtsilä, and Wärtsilä is a technology and service provider for the marine industry and energy business on land. I'm part of the marine business, and for this industry we sell engines, fuel handling and storage solutions, exhaust gas treatment, propulsion, and all kind of digital optimization solutions. We are a technology provider and a service partner of the industry, so we are both in the new build and in the life cycle phase active. And in my role, I'm head of cruise, so I'm responsible for our activities within the cruise segment. Together with our network sales team, I mainly advise customers about new technologies, about how we can improve their business and make their ships run better. This is mainly focusing on technical operations, and decarbonization is absolutely front and center in those discussions.
Fantastic. So a lot going on. So as I mentioned, we're here to talk about decarbonization in the industry. I was thinking, Maikel, maybe we could kind of kick this off with a discussion of the current state of play. So, what are the industry's decarbonization goals, and how are things going overall?
Yeah, the industry is committed to net zero by around 2050. So that's kind of a commitment from the industry. If we look at the regulatory landscape, then it's more of a mixed situation. So we have the EU that has implemented EU ETS and Fuel EU Maritime, so a comprehensive set of regulations that is targeting the maritime industry and is giving at least a clear landscape of what it is that the industry needs to comply with. So even though this increases the cost of operation for cruise lines and the shipping industry in general, it's at least a clear pathway of where we stand today and where we're heading in the future, because it's kind of ramping up as we speak. The other side of the coin is the IMO. In the IMO, there was, as the maritime industry knows, there was a big meeting last year in which the net zero framework was coming up for a decision to adopt it, and that decision got postponed at least with a year. So that decision is coming up at the end of this year. It's uncertain at the moment what will happen. If there again will be no decision or it will be rejected, then I think that would be a situation where there is a lot of uncertainty, remains a lot of uncertainty into the market, because then the shipping industry and cruise doesn't know what will come in the future. The risk side of this, of course, is that countries individually will start to implement their own emission regulations. That would give a very much a fragmented landscape, which I think nobody wants. But there was a lot of opposition against the IMO framework as they laid it down. So there was kind of a carbon taxation element and a structure to reduce the greenhouse gas footprint of the fuel they were going to use. So it's a bit of a tense situation, if I'm honest, John. Well, we'll know at the end of the year, around October, more what will happen. Yeah.
All right. So everybody's agreed with the goal is to get to net zero by 2050. There's that interim point of 2030. IMO has some goals there, but it's my understanding the cruise industry is aimed to exceed those goals by 2030.
Yes, correct. 2030 has the target of 40% reduction compared to 2008. And if we look overall, the cruise lines are ahead of the curve. They have made great steps. And what I also see within the cruise industry is that with or without the IMO, the direction is clear for decarbonization. If you look at a cruise ship today, the investment is huge. The economic life of a cruise ship is well into the over 30 years or 35 years, give or take. Last week, I was at the MSC World Europa, which is a huge cruise ship, more than 200,000 gross ton. We with a delegation, we visited the engine rooms, the LNG tanks, etc. So if you look at this kind of equipment being put on new ships, so this is a very new ship, it's impossible to change it out, or impossible, it's economically very unfeasible. So the choices that you make today and that you put on your ship in terms of equipment most likely will stay there for the rest of the economic life of the ship. And that means that even though the IMO hasn't decided today, you still see that the direction towards decarbonization is clear, and it makes good economic business sense to move in that direction. So it's also very much kind of a safety precaution for cruise lines that invest in new ships to make sure that these ships have the latest decarbonization equipment installed.
Right, right. This is what some people refer to a little bit as future proofing, though I would argue you can never be 100% future proofed, but you do the best you can. But Maikel, you mentioned LNG, so let's talk about that a little bit. That was a major move by the industry, a very rapid pivot. Can you talk a little bit about the role of LNG in the cruise line's decarbonization journey?
He certainly has a big role to play. At Wärtsilä, we say green is not black or white. So it's there's a multitude of steps that we see cruise lines are taking today in order to prepare themselves for future regulations. One of them is reduction of energy consumption. The second step is cleaning up emissions. And the third step is to switch to low carbon and net zero carbon fuels. So this is where LNG kind of comes in. Maybe starting with the first one, reduction of energy consumption. So this is about energy efficiency. This is about the latest engine technology that really has made a tremendous step change in efficiency, propeller designs, optimized hull lines, but also digital solutions to optimize the use of the ship. So this is energy consumption reduction. The second step, cleaning up of emissions, is, for example, in the case of LNG, if you work with LNG, then methane slip reduction is extremely important to make sure that your greenhouse gas footprint is as low as possible. And the last step is to switch to low carbon and net zero carbon fuels. Here is biofuel coming in, so biodiesels, but also LNG. And this, in the last couple of years, has really taken the center stage as the dominant fuel option for particularly large ships. And if you now look at the order book in cruising, if you look at it in terms of gross tonnage, because these ships are measured in gross tons, then you see that more than 70% of the current order book is having LNG as a main fuel. So that says enough about how dominant this fuel option is. Maybe
we could just back up a little bit. Can you talk, Maikel, about how LNG actually works to fuel a ship? I mean, most folks are familiar with standard liquid fuels, that go into their automobiles. LNG is a little bit of a different thing. And then you mentioned methane slip. Maybe you could talk a little bit about that as being one of the challenges of burning LNG. Maybe help us with some of the basics here.
Yeah, LNG stands for liquefied natural gas. So you can store then a lot of energy which you need for shipping. It came to the market as an alternative for sulfur emissions. So that worked excellent. Later on, the discussion moved to decarbonization. LNG was also very effective at that. So it gives you, give or take, between 10 and 20% reduction in greenhouse gas emissions compared to diesel fuels if you have a good grip on methane slip. So if you combust LNG as a fuel, there is a small amount of methane which is escaping the engine unburned. And this is what we call methane slip. This has always been a focus at the engine makers, because why would you lose a valuable fuel? But it has really gotten a lot more attention, as methane is also a potent greenhouse gas. And it is also addressed and targeted within, for example, the EU regulations and IMO regulations to reduce those emissions. So there is, of course, an economic element, but there is also an element to maximize the reduction of your greenhouse gas emissions. At Wärtsilä, we really have put a lot of effort in reducing methane slip. And with our latest generation of engines, two-stage turbocharged engines, 46TS, the 31, the 25, all these engines have a market-leading low methane slip. And this has proven very effective. We see that in our discussions with customers, methane slip is front and center in all the LNG operators out there. So this is absolutely a key topic, and it is making good economic business sense to invest in technologies that keep these emissions as low as possible.
So again, going back to the automobile analogy here, there's only one kind of fuel that can go into your particular car. And you put a diesel fuel into a petrol car, you're going to have big problems. And the reverse is also true. But the engines manufactured today for cruise ships can burn a number of different fuels while realizing all these efficiency gains that you've talked about. And I think that's fairly amazing. Fuels can vary widely that they can burn. And it's, I mean, that in and of itself is a major technological achievement.
Absolutely. The LNG engines that we provide to the market, they are in fact dual fuel engines. So these engines can run on LNG as a main fuel, but they can instantly switch to diesel as a backup fuel. And we see it today, unfortunately, and we've seen it in the past as well, is that the fuel market out there can be quite volatile. It can be disrupted. So this fuel flexibility is like an insurance policy for cruise lines to make sure that if one fuel type is not available, they can still continue operations on the kind of the backup fuel type. So I think that this has helped greatly in ramping up, for example, the use of LNG. I mean, it is ramping up quickly in terms of availability and bunker vessels, but it is still not available, of course, in every port. And dual fuel engines give you the ability to always sustain your operations and make use of LNG where available. The same goes for methanol. Dual fuel and fuel flexibility will be a requirement for many years to come. We would need to have quite a different fuel infrastructure market in order to go for a single fuel option. But fuel flexibility is certainly something that is worthwhile to invest in. And we have a lot of experience and success cases with that.
So, Michael, you talked about methane slip and how to reduce it. Is there any other new technologies on the horizon that you're working on to further increase efficiency for?
Yeah, so we have been very successfully in reducing methane slip, but the target is to really eliminate it. And we have now also developed what we call NextDF technology. This is a revolutionary combustion technology to reduce methane slip inside the engine, so optimizing the combustion process. And the reason we're capable of doing that is that this new generation of engine, they all have highly advanced digital controls, and everything is electronically controlled in terms of injection timing, valve timing, turbocharger pressures, etc. And this gives you the ability to really implement a new combustion technology. This is what we then call NextDF. And this really has made a quantum leap in reducing methane slip. So we really brought it down now, let's say, close to 1%. And I can hereby now also announce that we have this technology available on the large bore engines, the medium bore engines, and the small bore engines. So for large cruise ships, medium-sized or even small cruise ships, they can now all benefit from this NextDF technology. And given the dominant position that LNG has in the cruise ship order book, we think that this new technology is extremely suitable for cruise ships of all kinds.
Well, that's fantastic. So you mentioned that you're down to 1%. Can you give everybody a perspective on where it stood before? What kind of a percentage reduction have we seen?
Yeah. I can give you a couple of examples. EU has 3.1% as default value for medium-speed four-stroke engines. The IMO has a default value of 3.5% methane slips. So this is less than a third of, let's say, the default values. Our engines were already below the default value, but coming from around just below 2% to touching 1% or just above that. I mean, it's again a quantum leap ahead, and still we're not resting. I mean, the target clearly is to completely eliminate it, and Wärtsilä is committed to finding solutions for that.
Michael, I'd like to talk a little bit about the role of energy efficiency in data. So there's a lot of new tech out there. Wärtsilä have been deeply involved in that. Digitization is involved. There's continuous health monitoring of various ship systems, main engines, generators, etc. And then there's new approaches to maintenance, which may surprise some people. So can you talk a little bit about these new energy efficiency initiatives?
I would say working with data is not new for us. We have been working with data for the last 15 years. So we have collected a lot of experience in collecting data and how we can draw valuable insights from that data. One example is Eniram. That's a digital optimization solution. So it's now part of our Voyage Solutions offering within in Wärtsilä. You have Eniram Trim, Speed, and Voyage. So this is giving you a tool that is giving you the insight: what is the optimal trim for my ship? What is the optimal speed and voyage for my ship? Which is not the straight line from A to B. I would say these type of digital optimization solutions are widely used within the cruise industry. We have many references, and I would say any professional cruise line out there is working with some kind of digital fleet optimization solution of some kind, but also the hotel accommodation side, for example, HVAC optimization. It's a big energy consumption on board of a ship, and there's a lot of improvement to be made if you use the digital insights to really optimize the use of HVAC systems. Where we have also made great steps is how we use all the data points coming from the engine room to make energy efficiency gains. And these can be very practical examples. For example, the replacing of an fuel injector of an engine. So there is a standard lifetime for an injector, and for example, it has 12,000 hours, 8,000 hours. But if you carefully look at the data, then you can already see, for example, that there might be the economic life of the injector is still good, or the technical life of the injector is still good, but that there is a slight increase in fuel consumption. So using the data, we can then spot what is the ideal moment to replace the injector. And that is perhaps a bit earlier than the technical life. But if the fuel consumption is going up, then in terms of cost of emissions of fuel, it might still be good to do that a bit earlier. All these data points coming from the engine room are also giving us valuable and actionable insights, which allows us to inform the crew, this would now be a good moment to do, this would be a good, let's say, component to replace because it saves you money and emissions.
Mm-hmm. Yeah, this is fascinating to me that, you would essentially replace sooner what appears to be a perfectly good part. But that the AI technology catch that early and you have an opportunity to save. I think that's amazing. What I think this might be a difficult question to ask, Maikel. But when you think about all these efficiency technologies, can you give the listeners some idea of like what kind of percentages of fuel savings can you realize if you've got a nicely optimized system over just the old way of doing business?
I mean, of course, it depends case by case and customer by customer. But for one of the leading cruise lines, we have been really in multiple percents fuel savings that we have been able to achieve by doing the maintenance in a better way. So it wasn't that they were making a mess of the engines, but doing it on time. When, let's say, the data is telling us now is the right time to replace that. So this is about multiple grams of fuel consumption per kilowatt hour produced. And this is not some green technology that may be on the horizon 10 years from now, but this is available here and now. And I think that is certainly something which is catching a lot of interest within the industry.
For sure. And I mean, these are things that quickly pay for themselves, I assume, as well.
Yeah, we really see that maintenance decisions and should we go for an agreement that decision is almost moving out of the engine room and into the boardroom of the machine. So the system complexity of new technology on board of ships is increasing. There is a new set of fuels that is entering the market, but this focus on operating at peak efficiency, I would say the industry is laser focused on optimizing efficiency. And this is a topic that is absolutely at all levels within the cruise lines. There is a focus on it. Efficiency is also what you hear when you hear the top executives speak. This is something they focus on a lot of the time. So it's getting more and more known that using the right data points is giving you the possibility to operate your engines within the most efficient range, but also that good upkeep of the engines is really saving you a lot of fuel consumption and reduces the normal wear and tear and deterioration that go with that. I think it's the combination of the data with the OEM expertise and the dedicated support team that Wärtsilä, with our agreement solutions, are offering to our customers. 90% of the issues we're able to solve remotely. 80% of the issues, of the technical issues, are solved within the same day. And there is a 25% reduction of unscheduled maintenance costs. These are a couple of very powerful percentages that are important for cruise lines to optimize their operation. That combined with the ability to increase your fuel consumption is really making that this maintenance topic and agreement topic is becoming a boardroom decision these days.
You teed up earlier the topic of future proofing, and a cruise ship is a very, very expensive capital asset, and regulations change over time, technologies change, new fuels become available. I wanted to have you talk a little bit about, how does your company work to, as much as possible, to future proof a ship?
One of the things that our company is doing is that we consistently invest in R&D and new technology. The average spend is between 4 and 5% of our net sales is going into R&D. And this is not something we did last year, but this is a consistent figure over a long period of time. And that gives us an R&D pipeline of fundamental technology development, so that we know, for example, how do we combust methanol, or how do we combust hydrogen or ammonia. Not saying that's a logical fuel for cruise, but we have a broad range of technologies where we are doing R&D on. And then when there is a product market demand, so there is a market segment within cruise or the energy business that would like to use that fuel option or would like to use that technology option, then we productize that. So, for example, cruise lines. A big cruise ship these days is sitting closer to $2 billion than $1 billion, which was a number of years ago. So the investments are tremendous. Economic life of 35 years plus. They want to have certainty that the partners they work with, that they are ready for the future with their R&D program. And we are getting some very senior executives visiting us at the STH in Vasa, which is our main R&D site where we're doing cutting edge technology development. I can honestly say each cruise line that visits us there comes back inspired in terms of there is so much possible on the technology front. There is so much potential in engine technology to further reduce emissions, to increase engine efficiency. So we have brought methane slip now back to roughly the 1% mark. It depends a bit engine type by engine type, but that's, let's say, a reasonable ballpark figure of what cutting edge technology is capable of, but we're still pushing it further down. So we are confident that in a number of years from now, we will make another step change to reduce that further. I don't think we have seen the highest engine efficiency yet, what we are able to achieve from our engines. If you look at an engine, it's an extremely flexible energy converter. So the heat coming from the engine is also further used on board of a cruise ship. So there is heat recovery systems, and we have made tremendous step changes there as well. So we have now also on our large bore and medium bore engines what we call heat recovery plus system. So that means that not only the cooling water system is actually usable as heat, but also the lube oil temperature is usable heat. So that means actually that the engine, compared to other energy converters, is actually the leading product out there. And we believe that will remain so. Still, we're working with other technologies as well. So battery systems are entering the market, and we have a lot of experience in implementing battery systems on board of ships. In fact, we don't manufacture batteries ourselves, but we are the largest hybrid technology provider in the marine industry, whereby we source from other battery technology out there in the market, and we make sure that is fitting and integrated correctly into the electrical system of the ship. And this is something that we do for many cruise lines, also other shipping segments, so ferries and merchant, for example. So we see that next to the engines, there are other technologies which are also entering the market, and they also have a place. So there we then take that integrator role, which is important, of course, to cover as well.
Yeah, I agree wholeheartedly with that. Maikel, we're getting near the end of our time together, but I did want to touch on two final topics. So we've talked up to this point mostly about fossil fuels. I'd like to maybe just touch on, and this could be a topic for a whole separate podcast in and of itself, but synthetic fuels not derived from fossils, to discuss a little bit carbon capture. So you reduce the amount of carbon coming out the stack, but you never, it's never zero. But there's ways now that one can efficiently capture carbon before it is even released into the atmosphere. So you want to say a little bit of something about synthetic fuels, non-fossil fuels, and this carbon capture technology?
So the fossil-based fuels, either liquid or gas, there's LNG. So we all know that. Clearly, we see that biofuels are now entering the market. So biodiesel, if you your existing fleet that has been working with diesel or HFO needs to switch to a portion of biofuel in order to remain compliant. We see that also with LNG, that there is now also bio-LNG entering the market. The good thing of bio-LNG is that you can use it inside the existing infrastructure, so you do not need to change anything on the ship or on, let's say, the bunker vessel or the whole supply chain going to that ship. So it's the same molecule. You can blend it in at any ratio which you like. Today bunker bio and tomorrow again bunker fossil if it is not available. So it's an extremely flexible fuel option in terms of LNG. And the same goes for synthetic fuels. So with synthetic fuels, the production starts with the manufacturing of green hydrogen. So that could be with wind power, solar, you produce green hydrogen. And then with that green hydrogen, you produce any of the fuel options that we are using. And methane is basically CH4, so one carbon with four H atoms, four hydrogen atoms. That would be fantastic fuel. I mean, this is very little in terms of availability, but bio-LNG is now coming. So we see that you could almost say that it's not LNG that is changing, but it's the fuel itself that is evolving over time. This is something that is really helping the industry to move forward. Another technology that we are now also promoting is carbon capture and storage, as you mentioned, John. We see, for example, that there is a whole range of ships out there that still needs to rely on fossil-based fuels because these are existing vessels. The same goes for cruise ships, of course. These ships could make use of what is called carbon capture and storage. So the same as a scrubber installation is used to remove sulfur from the exhaust emissions. A similar type of technology could be used to remove carbon from the exhaust emissions. So without going too deep, first there is kind of a scrubber trap where you remove the sulfur from the emissions, and then there is a similar trap but you remove carbon from the exhaust. This carbon is then stored on board in a tank, kind of liquefied, it's stored in a tank. We have released a pilot project at the end of last year. That's a ship which is in operation. It's a chemical tanker actually from a Norwegian owner, Sifling. And this ship is now in operation. It's capturing 70% of the carbon.
Wow.
We have found out that 70% capture rate, that's where the sweet spot is in terms of energy consumption and how much carbon we can use, we can capture from the exhaust. But if you think about it, if that would give you a 70% reduction of your carbon emissions, you need much, much less biofuels in order to comply with future regulations. So this ship is an example that's already capable of being well ahead of the curve. I think, to be fair, it would be quite a major upgrade to install a carbon capture and storage system. So I'm not saying this is a solution for every ship, but certainly ships that have sufficient economic life ahead of them, this could be certainly an option to investigate to, hey, how could this help us move in the right direction? And again, 70% carbon capture is really a step ahead.
This has been a fascinating conversation. So you'll be at Seatrade this year. Do you want to let folks know where they can find you?
We'll be at Seatrade. The Wärtsilä team will be there, so do stop by. We are at the VIP lounge at the conference. Stop by for a cup of coffee and a good conversation. I will have several panels, and my colleagues will be available to discuss with all of you. So do stop by.
Fantastic. And you can find me at the Safety and Sustainability Theater on the main show floor. My booth number is 1259. I'm over there near Rena and Fincantieri. So Maikel Arts, head of cruise at Wärtsilä. What a fantastic conversation. Thank you so much.
Thank you so much, John.